In the first Chapter 3 video, we discussed the univariate procedure. And the univariate procedure produces a number of summary statistics by default for each of the variables analyzed in a selected data set. Next, we look at the means procedure. The means procedure is a little briefer in its output than the univariate procedure, and we can select specifically which statistics we wish for the means procedure to produce. So first, just looking at the basic syntax for the means procedure. Again, we have a proc means statement, and we specify the data set on which we wish this procedure to operate. Then for the proc means statement, we have selected options here, additional things we can choose, specific statistics that we want computed, and here we'll talk about those options there on the next page. We have a by statement. Remember, so if we have a by statement, what that means is that our data were sorted by this variable previously. So there must be a compatible sort. The by statements don't have to exactly match a previous sort procedure, but they must be compatible. And so that is an optional statement. Here I also list a where statement. We have a where statement we could also use on the univariate procedure. In fact, for any of these procedures, the where statement is also an optional statement, and we can't really use it yet until we talk about information in Chapter 4 on data step 2. We can identify one or more class variables, and so this has a similar effect as the by statement. Class statement does not require our data to be sorted as one of the advantages of it. There are other statements we can use also with the proc means procedure. These statements are a variable statement where we can specify here generically n variables. In practice, you don't put an ellipsis in here, but you fill in all of the variable names. So that's the VAR is typically short for variables. And so you can list the variables that you would like the means procedure to analyze, and these must be numeric variables. And then if we wish to output any of those summary statistics to a new SAS data set, we can do that in an output statement. Out equals and specify a new SAS data set name following naming conventions for SAS data sets, and then we list the selected statistics and new variable names we wish to output in this output statement, and those occur before the semicolon, and so we'll look at a template for that. So when we talked about proc means, we said that there were some options, and so I had that word options kind of enclosed in those inequality symbols, and that's consistent with SAS literature too. So if you start looking at SAS help, it's going to specify options using that same kind of notation. So for the for the proc means statement, we can ask for a number of non-missing values or sample size, number of missing values, etc. And so the range of a data set, meaning the difference between the high and the low score, the sum, the mean, the variance. So be careful here. We have variance as a requested statistic, not to be confused with the VAR statement, and so forth, standard deviation. And so then there are several things listed then on page 47 in your textbook. Near the bottom of this list, we have a T statistic and PRT. So these are conducting a test for whether a population mean is equal to 0 or is it something different. PRT is the observed significance level, or p-value, for that two-tailed test, and so that this is much briefer perhaps than using the mu0 option that we saw in the univariate procedure. You can request a confidence limit for the mean, or if you want one-sided confidence limits, you can specify those. It will give you 95% unless you use the alpha option, and so in the alpha option you specify this value or probability for p, and that has to be a value between 0 and 1. So typically confidence intervals require a value of p here in this alpha statement of 0.1 or something smaller. So 90%, 95%, 98, 99, those are typically what we see for confidence interval, the value of the confidence. If you wish to run this procedure and all you really are trying to do is recover what's in an output statement or the output statistics, a no print option can be one of the things that you put on the proc mean statement. There's also a no print option for proc univariate. We didn't demonstrate that, but if we're not interested in what the means procedure is going to print out, and if you have a by statement you could generate pages and pages of output, the no print option is one way to suppress that output but still recover a data set. If you're not recovering a data set, this no print option really doesn't have any value to you. So if we look at objective 3.4, we want to run the means procedure for the SAS dataset instruction that we had been using for the univariate procedure, and we want to examine the default output. That is, we're going to select no options. And so in this statement, it looks a little peculiar here perhaps because I just wrote proc means data equals instruction and I have a title statement. There's no VAR statement. So if you go back to the book and if you looked at that, the VAR statement is optional. If you leave it out, it will operate on every numeric variable in the dataset instruction. So even if you called them programs 1 and 2, it's going to give you summary statistics for program because they were given numeric values 1 and 2. We have given them numeric values A and B, or pardon me, alphabetic values A and B, so therefore we're not going to get that analysis. But so what we'll look at is in the basic output for the means procedure for this dataset instruction. So if you have stopped your SAS session since the previous video, that is, you've exited SAS after doing all of the proc univariate objectives, and you come in and you just enter this isn't going to work because it shows on screen, this is my initial log screen, and so therefore the instruction data set is not created here. And so that we may have a program where we have all of the information that we saved from the first part of this chapter. So we have the creation of data set instruction, we have the univariate procedures, objectives 3.1, 3.2 through 3.3. So we can have all of these in here. We can choose to leave all of those in here and run everything again, just appending the new proc means information, or we can skip over these and delete them, but at a minimum what we must do is run this data set instruction. And so you've seen me do it a couple of times already, but if I come in here and I insert a run statement, the blank line is optional. That's really more for visual separation for me. I see that the enhanced editor is putting in the horizontal lines anyway, but I can highlight all of this data step and pick up the run statement and I can submit it, check the log. So now I do have 30 observations and 2 variables in the dataset instruction, and that's what I wanted. Move back to the editor. I don't care to repeat these that we've done in the previous video, so if I don't want to run those, I can delete them. If I want to save this program and keep those things intact, then I can just add the new objective 3.4 here. Okay, so then we can highlight this part and let's just look at what is the default information that we get out of the means procedure. Just say proc means on dataset instruction, and so I run this and I get only output for the means procedure. And so then it tells me here that I have 30 observations and what the average or mean is, the standard deviation, the minimum, and the maximum values. So that is the default information. If I request no statistics as options on the proc mean statement, I'm going to get these 5 pieces of information. Okay, so if we move on then to objective 3.5, in objective 3.5 we're to compute the minimum, the maximum, the mean, standard deviation, sample size, and the coefficient of determination for each of the programs in the instruction data set. Use a class statement to identify the levels of programs as the subgroup. Alright, so we move back to our editor, and off screen I created the code so that I can paste it in here so you don't have to watch me type. Okay, now then these are the statistics and the order they were specified in Objective 3.5. If you just put CV in, okay, because we already know it generated these 5 pieces of information. If we just include CV, then that's all we're going to get. So if you request one thing that's not in addition to the default information, it means you need to specify everything that you want. And so you want to specify all the statistics that you want and the order you want them to occur. It's because that with this output, then once you run this, if you put it in the order you request, so here's our old one up above, this is the default order, and so I requested the sample size, min, max, mean, standard deviation. So I've got things in a little different order than what they were up here, and then finally I have the coefficient of variation, here at the end, which is the standard deviation divided by the mean and multiplied by 100%. Right, so it tells me exactly which variable it's working on, score. Did that in both cases. The class statement generated this first column for program, or the class, and it was A and B. If we would have had, say, 3 programs, we'd have a row C, 4 programs, a row D, etc. Okay, so it was able to do this for each of the programs using only the class statement. I got the statistics I wanted from minimum through CV, and the order I wanted them in. And so that if we, as we saw in Chapter 1, if we created our variable score in title case, that is where score, the S was capitalized, then we could start to begin to tailor this so that this is just if it's exactly the statistics we need for a report, we can cut and paste into a report if that is our objective. In Objective 6, what we're asked to do is to add an output statement to recover the minimum, maximum, and range in a SAS data set to be named 6. So we'll come in here and enter that information. Examine the contents of the new data set by adding a print procedure. Okay, so that means after this we can write proc print data equals, we want to print data 6, not data instruction. And we need a run statement. Okay, now things to notice here. We requested that the minimum and the maximum be computed and printed as part of the proc means output. I also have those being recovered here. I did not request the range to be printed, but I'm asking the range to be put into the output data set 6. Okay, so if I print these, and then this is going to be our Objective 3.6. Okay, so if we run this now, it repeated our 3.5. Okay, we had no change there. Objective 3.6, this is the contents of data set 6. Okay, notice that whenever I output this, I have a blank here for program because this is all 30 observations together. That's what this frequency tells me, and gives me the minimum score, the maximum score, and we can verify those from the printed output for each of the programs. And then we have the range, which we can't confirm above. Well, the first row actually we can't confirm from these at all because these are A and B separated. So, well, for min and max we could, but for other statistics we could not do that. So it does it for all of the data set and then for each level of the class variable. So again, if we would have 3 or 4 programs, we'd have 3 or 4 more lines after that first observation line. So remember, when we use proc print, SAS automatically tucks this observation number here in the first column, and we could have suppressed that by simply using the no obs option, just as we saw back in Chapter 2. Now when we go back to the results viewer, just a reminder, we used a class statement for this instruction data set in the univariate procedure and we created an output data set, and when we printed it, it doesn't do this. It doesn't give us this observation 1 line. It did observations 2 and 3. That is, it printed the requested statistics for each program, but it did not print the requested statistics for the entire data set together. So depending upon your end usage, which form of the data set do you need? And so it's important that if you're going to pick this data set up and use it in other applications, that you know if that line 1 is in there or not. So we always can run a quick proc print and take a quick look at the contents of a data set. In your textbook, I encourage you to look at the illustration regarding the handling of multiple variables in the VAR statement and how you would specify multiple output statistics in a data set. So there is a modification, or it just occurs just before Objective 3.6. Now the other thing we could have done, instead of using a class statement, we could have done this using a by statement. So whenever we use a by statement, we have to remember to sort by program so that this is compatible to the by program, the by statement used here. So you can't, we can use both a by and a class statement, but they can't specify the same variable. So by program and class program, we shouldn't do that. Okay, here we have a very simple data set, so we don't have other variables that we could have chosen from here. But this by program has to match a sorting that's been done here. So now this proc sort, I've got it right here above the means procedure used in Objective 3.7. It could have occurred anywhere earlier in the program. If I have it earlier in the program, it is not necessary to repeat it. And so if we scroll up just real quick, I don't have it on any of these univariate procedures that I had in the saved version of this program. We did look at a modification, I believe, with the by statement on this Objective 3.3 previously, but that's not in this version of the program. So there hasn't been a sort take place. It's not a big deal for a small data set, but if you have a very large data set and you constantly are sorting it, it does take up computing time, and so it does slow your program down. For the size of the programs or data sets we're handling here in the class, it's not real critical. However, I want you to be efficient in how you select those sort procedures. It's not necessary to sort by score. If you're wondering, do I have to sort the responses? You do not. Only the variables specified in the by statement. Okay, so this is Objective 3.7. We're going to output again the minimum and the maximum score and the range, just as we did before, but this time using a by statement, and then we're going to print that to have a look at it. So when you use a by statement, notice you get a table for the first level of program, which is a table for program B, separate from each other. And so this is all of the means procedure, whereas what we saw before, if I scroll up, using a class statement, it was all in one table such as this. So it depends on what the appearance of the output do you prefer. Now, whenever we print the output data set, so just at the top of our results viewer, this is our reminder of what the class statement in the procedure then with an output statement looks like. So I get the summary of the entire data set as line 1. When I use a by statement, I don't get that information. And this looks more like what happens when you use either a by or a class statement in the univariate procedure. In the means procedure, it makes a difference. In the univariate procedure, it did not. In Objective 3.8, we're asked to compute a 99% confidence interval for the mean, use alpha equals 0.01 in the conclusions for the test that we look at. So we're looking at the default test for the population mean. So here I'm doing this using a class statement. It could also have been done using a by statement for the variable score. And so I'm specifying what I want it to do here. So specifically we're asked for the t-test and its significance level and the confidence limits for the mean, and because we want 99%, I need the 0.01 specified for alpha in order to get the right confidence. Okay, the mean and the standard error was not part of the default information, but because I know that the t-statistic is computed by taking the mean divided by the standard error, I wanted to put those two pieces in here also. So when I run this program, or this block of code, objective 3.8, so for each program I have the number of observations, the mean and the standard error of the mean. So this is standard deviation divided by square root sample size. If I take 76, divide it by this 2.5, I'm going to get the 30.31. Likewise, I get the 45.14 in the second row. The p-value here, so what's being tested by this t-statistic and by this p-value is whether or not the mean for program A is equal to 0 and the mean for program B is it equal to 0. And so these are absolutely huge because our data is nowhere near a value of 0. You can also look at the confidence interval. So the CLM option generates both of these two columns, and so for program A, the true population value for the mean is between 68.64 and 83.79, and likewise we can make that interpretation for program B. Okay, so if we're going to write our test conclusion, we would find that our means are significantly different from 0, citing these two t-values and p less than 0.001, pardon me, 0.0001 for each of the programs. The value of alpha that we saw in the program, the value of alpha here affects only the confidence interval. The value of alpha does not affect t or the p-value associated with it. T and the p-value associated with t are functions of the data only. So therefore you can change the alpha and you'll get a different confidence interval, but t and its probability associated with that t-statistic will always stay the same. So whenever you're making your comparisons and your results, you're comparing this to your nominal alpha level that we have in mind, and so that this 0.0001 is certainly smaller than our selected alpha of 0.01. Now in the univariate procedure, we did look at a hypothesis test situation where we were comparing the mean to 75, and given the tools we have so far, we cannot do that using the means procedure. But once we learn some information from data step information 2 in the topics in chapter 4, we can use the means procedure to do that, and we will revisit the means procedure and testing for other values for population means values other than 0. We'll do that in chapter 6. Now, as I've been programming here, hopefully you're seeing some other things that maybe you're not seeing in the books, and I didn't realize I could just grab a piece of the code and pick up the run statement to get a new and revised output. And so that's one of the reasons for the video. There are things that I do on screen that perhaps give you a little more insight about how SAS works. Now, if you were down here to the end, you notice you have an editor window and we see an asterisk on this. It's untitled, an asterisk, meaning none of this has been saved if it's untitled. If I had opened an existing program, say Chapter 3 objectives, and I saw then Chapter 3 objectives and an asterisk after it, then I would know that I've made some changes to that program since the last time I've saved it. And so your changes could be as much as a single space. It could be more. So if I want to save all of this information in a program, I move to that active editor window, File, Save As, and then I look for where I want to send this. So I have a file called SAS Objectives on a USB storage device, and so let's just say I want to call this Chapter 3. objectives. And then it's going to add the .sas to that. Okay. And so notice it puts that title up here. It's down here on this bar, and if you let the mouse hover for a second, it shows you the complete name, since it's a little bit too long for the blank. And if I look up here and go, well, let's see, I need to make a change here. I really didn't want all those blank lines there. They're not hurting anything, so I deleted them. All I made was that change, and notice I have an asterisk here. So that means since the last time I've saved it, I've made a change. So it was very minimal what I did. So if I already have a name, then I can just click a quick save here by using the save button on the toolbar, or I can go back to the file pull down menus and save, or save as if I wish to change the location. With proc univariate, recall that we did see some histograms, and so in that class of what we call ODS graphics, we highlight more about ODS graphics in later chapters of the book. Proc means does not generate any of those kinds of graphics, so if you know you need those kinds of histograms using either one of these procedures, then you would have to pick proc univariate. So proc means is much simpler in its output, and so we can tailor it more specifically with what we want, but we cannot get graphics with it. That's just not available at this time. That's all for Chapter 3. We'll talk again in Chapter 4.